Start with the first one, introduction. This is a very important reaction for our life cycle. Okay? This is an important reaction which gives this product, okay, which is represented with the general formula CxH2OY. These are nothing but carbohydrate. So carbohydrates are prepared or synthesized in this photosynthesis process, okay, which takes up carbon dioxide and in presence of water, sunlight and chlorophyll converts it into these sugars or carbohydrates, and with the evolution of oxygen, which is again an important uh, life-saving gas. These carbohydrates are most abundant constituents of plants and animals. Okay, plants have more proportion of these carbohydrates. As we know, the green plants can synthesize carbohydrate with the process of photosynthesis. Now, most of them have empirical formula which is written like that CxH2OY and were defined as hydrates of carbon. So, by the word itself, we can understand they were defined as hydrates of carbon, which is represented with this formula CxH2OY. But not all the carbohydrates follow this formula or fit into this empirical formula. There are certain exceptions, for example, acetic acid, okay, which fits this formula but is not a carbohydrate. Okay, and this is another example, deoxyribose, which doesn't fit in this formula but is a carbohydrate. So there are exceptions of both the types. Okay, compounds which fits in this empirical formula but they are not carbohydrate, and another are the group of carbohydrate which doesn't fit in this empirical formula. So now the question is how to define these carbohydrate. So one important definition is given on the basis of the structure of these compounds, and it is like that: carbohydrates are polyhydroxyaldehydes or polyhydroxyketones, or the compounds which give them on hydrolysis. In the classification, now there is another word used for carbohydrate. Carbohydrate are also referred as saccharides. This saccharide is come from a Greek word known as saccharin. Saccharin meaning is sugar. So when we do the classification of these carbohydrates, the word used most of the time is saccharide. Okay? So carbohydrates are classified into three broad groups: monosaccharides, oligosaccharides, and polysaccharides. The monosaccharides are further subclassified or can be classified based on two criteria. First, the number of carbon atom present in the monosaccharide. If a monosaccharide consists of three carbon atom, it is called as trioses. If it consists of four carbon atom, it is known as tetroses. Five carbon atom, pentoses, so on and so forth. If a monosaccharide consists of, say, six carbon atoms, then it will be referred as aldoses, sorry, hexoses. So these are the subtypes of monosaccharides or classification methods depending upon the number of carbon atom present. Another way of classification of monosaccharide is depends on the functional group present. Okay. Monosaccharides, or when we define carbohydrates, we say these are polyhydroxyaldehydes or ketones. So we are aware that these carbohydrate consist of aldehyde or ketone functional group in their structure. So those monosaccharides are further classified depending upon which functional group is present in their structure. Okay. An aldehyde containing monosaccharides are known as aldoses, whereas a monosaccharide consists of ketone functional group are known as ketoses. If a monosaccharide unit consists of aldehyde as a functional group, the suffix oses is used for aldoses. Whereas if it consists of a ketone as a functional group, okay, and known as ketoses, then the suffix uloses, uloses, is used while naming the monosaccharides. These monosaccharides are crystalline substances with sweet taste. They are soluble in water, okay, and they can be represented with a general formula CnH2O N. Now, next group of carbohydrates are oligosaccharides. These are also crystalline compounds, soluble in water and sweet in taste. These oligosaccharides on hydrolysis gives 2 to 9 monosaccharide units, and depending upon the number of monosaccharide unit obtained after hydrolysis, they are subclassified into disaccharide giving 2 monosaccharide unit, trisaccharide gives 3 monosaccharide unit, tetrasaccharide gives 4 monosaccharide unit, etc. The oligosaccharides are further classified into disaccharide, trisaccharide, tetrasaccharides, etc. A disaccharide, for example, sucrose, which is having molecular formula C12H22O11, which on hydrolysis gives glucose plus fructose. Sucrose is a table sugar, okay, that gives glucose and fructose. These are the two monosaccharide unit. Okay. So the disaccharides have general formula CnH2O N-1, whereas the general formula for trisaccharide is CnH2O N-2. Example of a trisaccharide is raffinose. It has general formula C18H32O16, which on hydrolysis gives 3 monosaccharide unit: glucose, galactose, and fructose. Next group of carbohydrates are polysaccharides. These polysaccharides are more complex than oligosaccharides. They are high molecular, they are insoluble in water, amorphous. Okay. When we talk about monosaccharides and oligosaccharides, we said these are crystalline compounds, whereas polysaccharides are amorphous and insoluble in water. Okay. They on hydrolysis gives large number of monosaccharide units. Okay. For example, starch, cellulose, dextrin. These are the polysaccharides, okay, made up of glucose unit or monosaccharide unit. The general formula for that is C6H10O5N. These polysaccharides are further subclassified depending on the monosaccharide molecules they yield. For example, if on hydrolysis polysaccharide gives same type of monosaccharide unit, then they are called as homopolysaccharides. Example, cellulose, starch, glycogen, insulin, etc. These are the polysaccharides which on hydrolysis gives same type of monosaccharide units. Whereas the heteropolysaccharides on hydrolysis gives different types of monosaccharide unit. For example, hyaluronic acid and chondroitin. These are the examples of heteropolysaccharides. This is the classification of carbohydrate, broadly classified into three types, and then they are further subclassified. Now let's move towards the next point. The DL notations, when we write a sugar or carbohydrate or monosaccharide unit. So carbohydrates, when represented in Fisher projection, the prefixes D and L used to specify the configuration at the carbon atom which is farthest from the aldehyde or ketone group. In other words, we can say the penultimate carbon atom which is chiral in nature. For example, we have glyceraldehyde which is represented in this Fisher projection. Here we have two enantiomers of glyceraldehyde, okay, or the mirror images. Here, in this first structure, we can see the hydroxy group attached to this chiral carbon is on the right hand side. Therefore, it is denoted as D-glyceraldehyde, okay, or the prefix used is D. Whereas in this another molecule, the hydroxy group OH is on the left hand side of this chiral carbon. So the prefix used is L and it is named as L-glyceraldehyde.